Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss constructions. In the previous class, we have discussed the concepts of exercise 13.8 in the chapter surface areas and volumes. I hope you have understood the concepts of exercise 13.8. And I hope you have done the first five sums in the exercise 13.8. Haven't you, my dear children? Right. Now, today, let us discuss the concepts of exercise 11.1 in the chapter constructions. Are you ready to listen the class, my dear children? Right. Now come to introduction. In earlier chapters, the diagrams which were necessary to prove a theorem or solving exercises were not necessarily precise. They were drawn only to give you a feeling for the situation and as an aid for proper reasoning. However, sometimes one needs an accurate figure. For example, to draw a map of building to be constructed, to design tools and various parts of a machine, to draw road maps, etc. In all these cases, we had to draw an accurate figure. To draw such figures, some basic geometrical instruments are needed. You must be having a geometry box which contains the following. Okay, my children, right. The first one, a graduated scale, on one side of which centimeters and millimeters are marked off, and on the other side inches and their parts are marked off. This is the first geometrical instrument we are using to draw the constructions. Okay, my children, right. And the second geometrical instrument is a pair of set squares, one with angles 90 degrees, 60 degrees and 30 degrees, and other with 90 degrees, 45 degrees and 45 degrees. This is another geometrical instrument which should be in the geometry box to construct geometrical figures. Okay, my children? Right. Now come to the third geometrical instrument, a pair of dividers or a divider with adjustments. Okay, my children, this is also a geometrical instrument to construct geometrical figures. Okay, my children, right. A pair of compasses or a compass with the provision of fitting a pencil at one end. We frequently use this one, compass, to draw the geometrical figures. In this chapter, we use compass, mainly a graduated scale and a compass. These two will be used very frequently to draw geometrical figures in this chapter. Okay, my children? Right. And last and final, a protractor. These five geometrical instruments should be required to draw geometrical figures. Okay, my children? Right. Normally, all these instruments are needed in drawing a geometrical figure, such as a triangle, a circle, a quadrilateral, a polygon, etc. Okay, my children, with the given measurements. But a geometrical construction is the process of drawing a geometrical figure using only two instruments, an ungraduated ruler, also called a straight edge, and a compass. Okay, my children, in the construction where measurements are also required, you may use a graduated scale and a protractor also. In this chapter, some basic constructions will be considered. These will be used to construct certain kinds of triangles. Understood this point, my children? Previous slide, I told you clearly to construct geometrical figures, we use a scale, a ruler, and a compass. If the measurements also required, then we use graduated scale and protractor also. Otherwise, we use only ruler, that is a scale, and compass only. Please remember this point, my children. Understood this point, my children? Right. Some basic constructions. Okay, my children, what are basic constructions? In class 6th, you have learned how to construct a circle, the perpendicular bisector of a line segment, angles of 30 degrees, 45 degrees, 60 degrees, 90 degrees, and 120 degrees, and the bisector of a given angle without giving any justification for these constructions. Yes, sir, Namacharan. In this section, we will construct some of these with the reasoning behind why these constructions are valid. Okay, my children. In the previous classes, you have constructed all these geometrical figures. Perpendicular bisector of a line segment, angle 30 degrees, 45 degrees. We have used protractor to construct 30 degrees, 45 degrees, 60 and 90 degrees and 120 degrees. And bisector of a given angle also. In all these constructions, just we have constructed a geometrical figure and we wrote the steps of construction only. That's our children. But in this class, in addition to that, we write justification also why these constructions are valid. Understood this point, my children? We are going to some other level, next level. In the earlier classes, we have constructed geometrical figures and we wrote steps of construction only. We stopped by that part. But here we are adding, in addition to that, justification also. Please remember this point, my children. In this class, not only constructing geometrical figures, not only writing steps of construction, in addition to that, we are writing justification for the construction. Why the construction is valid. Understood this point, my children? Right. Now let us write justification, whether our construction is valid or not. Okay, my children, right. This is our construction. Okay, my children, right. Let us see how this method gives us the required angle bisector. Okay, my children, right. Join DF and EF. Let us join these 2 points DF and EF. Understood this point, my children? Right. In triangles BEF and DEF, if you observe this figure, you get two triangles, namely BEF and BDF. Yes or no, my children? Two triangles are there. In these two triangles, let us compare the parts of the triangle. BE is equal to BD because they are radii of the same arc. Yes or no, my children? Right. Next, EF is equal to DF, the arcs of equal radii. EF and DF also there are arcs of the equal radii. Understood these steps, my children? BF is equal to BF, that is a common side. Yes, sir, my children. Right. So in these two triangles, we compared three sides in the one triangle is equal to the corresponding three sides in the another triangle. Therefore, we say that triangle BEF is congruent to triangle BDF. Understood this step, children? By SSS congruence rule, triangle BEF is congruent to triangle BDF. Okay, my children? Right. This gives angle EBF equal to angle DBF by CPCT. Angle EBF equal to angle DBF. These two angles are equal. Means this ray BF bisecting the angle ABC. Understood this point, my children? Now come to the second construction, that is to construct the perpendicular bisector of a given line segment. Okay, my children, let us discuss this construction, the perpendicular bisector of a given line segment. Okay, my children, right. Given a line segment AB, we want to construct its perpendicular bisector. Okay, my children, the measurement of line segment AB may be anything, but we want to construct its perpendicular bisector. Okay, my children, right. See here, my children, this is a line segment AB. This is a given line segment. So to construct the perpendicular bisector of this line segment AB, we follow these steps. We have to take A and B as centers. We have to take the points A and B as centers, and the radius more than half of the line segment AB. Draw the arcs on both sides of the line segment AB, on both sides like this. We have to draw by taking A as center. We have to draw an arc here and here, and by taking the B as center with the same radius, you have to cut this arc and cut the second arc. Okay, my children. Then these two arcs intersect at a point, and these two arcs intersect at a point. Then we got 2 points. Now join these 2 points. We get a line. This line is nothing but the bisector of the line segment AB. Understood this point, my children? Right. Now let us write steps of construction. Step 1. Taking A and B as centers, and radius more than of AB. Draw arcs on both sides of the line segment AB to intersect each other. We have to draw the arcs to intersect each other. This is the first step. Okay, my children. Right. Come to the second step. Let these arcs intersect each other at points P and Q. Join PQ. Okay, my children. They are intersecting at the points P and Q. Now join these 2 points P and Q. Observe the figure 11.2. Now step 3. Let PQ intersect AB at the point M. Then the line PMQ is the required perpendicular bisector of AB. Understood these steps of construction, my children? Right. Now let us write the justification whether this construction is true or false, whether it is valid or not. Okay, my children? Right. Justification. See here, my children. Let us see how this method gives us the perpendicular bisector of line segment AB. Okay, my children, join A and B to both P and Q to form AP, AQ, BP and BQ. Okay, my children, understood this one? We have joined AP, AQ. Similarly, BP, BQ. Okay, my children, right. In triangles PAQ and PBQ, here we get 2 triangles PAQ and PBQ. For this line, left side is one triangle PAQ and right side is another triangle PBQ. Okay, my children, right. AP is equal to BP, arcs of equal radii. Yes or no, my children? AP equal to BP, both are of equal radii. They are arcs of equal radii. Understood this step, my children? Right. AQ is equal to BQ. AQ is equal to BQ. These are also arcs of equal radii. Understood this step, my children? Right. PQ is equal to PQ. That is a common side. That side is a common side in the 2 triangles. Okay, my children? Right. Therefore, triangle PAQ is congruent to triangle PBQ by SSS rule. Understood this step, my children? In these 2 triangles, we compared the sides of one triangle to the 3 sides of the another triangle. Then we got the 2 triangles are congruent. Okay, my children, understood this step? Right. So, angle APM is equal to angle BPM. Angle APM, this angle is equal to angle BPM. So, this angle, these 2 angles are equal. Okay, my children, this angle APM is equal to angle BPM. Okay, my children? Right. Now, in the triangles PMA and PMB, here again we take PMA and PMB. Here we are taking 2 triangles PMA and PMB. Okay, my children? Right. AP is equal to BP. Okay, my children? AP is equal to BP. Previously we have taken, they are arcs of equal radii as before. Okay, my children, understood this step? Right. PM is equal to PM.
that is a common side. In these two triangles, PM is a common side. Okay, my children, understood this step? Right. Angle APM is equal to angle BPM. We have proved, already we have proved in the previous. Angle APM is equal to angle BPM by CPCT. We have proved here. So we are using that result here. Understood this step, my children? Right. Therefore, triangle PMA is congruent to triangle PMB. By SAS rule, these two triangles are congruent. Understood this step, my children? Right. So, AM is equal to BM and angle PMA is equal to angle PMB by CPCT. Understood this statement, children? AM is equal to BM and here AM is equal to BM. These two line segments are equal. Angle PMA equal to this angle PMA is equal to angle PMB. Understood this point, my children? These two angles are equal. Okay, my children? Right. As angle PMA plus angle PMB is equal to 180 degrees because they form a linear pair. So by linear pair axiom, the sum of these two angles is equal to 180 degrees. Understood this step, my children? Right. We get angle PMA is equal to angle PMB is equal to 90 degrees. Okay, my children? Because these two angles are equal and the sum of these two angles is 180 degrees, means this angle is 90 degrees and this angle is also 90 degrees. Yes or no, my children? Understood this step? Right. Therefore, PM, that is PMQ, is a perpendicular bisector of AB. Understood this step, my children? Therefore, we say that this PM or PMQ is a perpendicular bisector of the line segment AB. Understood, my children? Right. Now let us discuss third construction. To construct an angle of 60 degrees at the initial point of a given ray. Okay, my children, understood this question? Right. Let us take a ray AB with initial point A. See the figure 11.31A. We want to construct a ray AB such that angle CAB is equal to 60 degrees. Okay, my children, we have to construct angle CAB is equal to 60 degrees at the initial point A. Okay, my children, right. One way of doing so is given below. Okay, my children, right. Here observe this figure 11.31. Here two figures are given. This is 11.31. Here 11.31, 11.32. First a ray AB is given. At this initial point we have to construct angle 60 degrees. Okay, my children, right. To construct angle 60 degrees at the initial point A, first of all we have to take A as a center. And with some radius, we have to draw an arc. Okay, my children, which intersects at point D. Let us take A as center with some radius, draw an arc to cut the ray AB at the point D. Okay, my children, right. After that, with the same radius, take D as center. Now take D as center with the same radius, with the previous radius. Draw another arc to cut the ray AC to get to the point E. Okay, we got a point E. Join the points D and E. Join the points D and E. Then we get a equilateral triangle, an equilateral triangle, because AE is equal to AD and AD is equal to DE. So this is an equilateral triangle. We know that in an equilateral triangle, every angle is 60 degrees. Automatically, angle CAB is equal to 60 degrees. Right. Now come to steps of construction. Okay, let us write the steps of construction. Step 1. What is the step 1? Taking A as center under some radius, draw an arc of a circle which intersects AB, say at a point D. Intersects AB, say at a point D. This is the first step. We have drawn an arc. Step 2. Taking D as center and with the same radius as before, draw an arc intersecting the previously drawn arc, say at a point E. Understood this step, children? Right. Step 3. Draw the ray AC passing through E. See the figure 11.32. Then angle CAB is the required angle of 60 degrees. Okay, my children, understood these steps of construction, my children? Right. Now, let us write the justification of this construction, whether this construction is valid or not. Okay, my children? Right. Justification. For every construction in this class, we have to write steps of construction as well as justification also. In the earlier classes, we have not written this part. Steps of construction only we have written. But here we have to write justification also. Okay, my children, understood this point? Not only writing the steps of construction, we have to write justification also. Now, let us see how this method gives us the required angle of 60 degrees. Okay, my children, let us see this one. Join DE. Join DE. Then AE is equal to AD is equal to DE by construction. Yes, my children. Right. Therefore, triangle EAD is an equilateral triangle. Yes, my children. And angle EAD, which is the same as angle CAB, is equal to 60 degrees. Okay, my children, understood this one? Right.